With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? There is a hypothetical planet in the shape of a sphere and it is completely made up of incompressible fluid and it is having a mass of m and radius is r. Now, if the pressure at the surface of the planet is given as to be 0, then the pressure at the center of the sphere, we need to calculate the value. Okay, so we just draw our hypothetical planet. Let's say this is our hypothetical planet. Okay, now why would be their pressure? So for example, we just draw a sphere, okay, at a distance of small r. Let's say this is a sphere at a distance of small r. Okay, now on this sphere, basically it would be in 3 dimensions. So there would be a thickness of the sphere. So we call the thickness as to be dr. So dr would be the radius. So we just draw a thickness of this sphere. Now there on this thickness, we call this as to be our dr. Okay, so this would be consisting of mass. Let's call the mass as to be dm. Now due to the masses which are inside this sphere, there would be an attractive force. Okay, attractive force, and this attractive force would be causing a pressure. So the pressure value would be, basically we know that pressure is what? Pressure is our force per unit area. So due to this small force which is created due to this mass, so the pressure would be, we say that dp, this would be equals to df divided by, what is the area? Area would be 4 pi r square. Okay, 4 pi r square. Now what would be the value of our df? What would be the value of df, this force? Now df would be basically our gravitational force. Okay, so gravitational force could be written as electric field at the point multiplied by the mass dm. Okay, the mass dm of this strip. What is the gravitational field inside a sphere? We know that formula for the gravitational field would be equals to what? It would be gm divided by r cube into r, where r is the distance at which we need to calculate the gravitational field. We are calculating the gravitational field at a distance of r. Okay, multiplied by dm. How can we write the value of dm? Mass could be written as density times the volume. Now what would be the volume of this thin spherical shell? Volume of the thin spherical shell, this is equals to 4 pi r square multiplied by dr. Okay, this circumference, this surface area multiplied by the thickness. How to write the value of the density? So density value, we just make one more step, gm into small r divided by r cube, and density could be written as mass divided by volume, total volume, which would be equals to 4 by 3 pi capital R cube multiplied by 4 pi r square into dr. Okay, this would be the value. Now if we solve this, then our df would turn out to be, equals to this gm into r divided by r cube, then this would turn out to be 3m, then r square. So this 4 and this 4 would be cancelled, this pi and this pi would be cancelled. So 3gm r square divided by r cube into dr. So this would be our force. Now if we get to know the value of the force, then what would be the pressure? So dp would be equals to df divided by 4 pi r square. We can just divide this value by 4 pi r square. So it would turn out to be, after we divided, so it would turn out to be 3 times gm square into r divided by 4 pi r to the power 6, okay, into dr multiplied by dr. So this is our this small pressure created due to this small force. Now if we want to calculate the total pressure, we can integrate. Now what would be the limit of integration? So it is given that at the surface, at this point, pressure is 0. That means when small r is equals to capital R, the pressure is 0. So we put the limit. So lower limit we can put when this is equals to this small r is equals to capital R, pressure value is 0. And when we need to calculate the pressure at the center, that means radius should be equals to 0. So when radius is equals to 0, what is the pressure? Let's say the pressure is P. So if we integrate this, so this is simple integration, it would be P minus 0. Okay, now here we can take 3gm square divided by 4 pi r to the power 6. This can be taken as common. Now it would be just simple r square, r into dr, integration of r into dr would be equals to r square by 2. So it would be r square divided by 2. Now we can put the limit from this is basically r to 0. So here it would be P, this would be equals to 3gm square divided by 4 pi r to the power 6. And if you put the limit, so it would be 0 minus r square divided by 2. This would be the value. So finally the pressure would turn out to be, our pressure would be minus 3 gm square divided by 8. So 4 multiplied by 2 would be 8 pi, and 2 power would be cancelled, so it would be just r to the power 4. Now negative signs show that it is a pressure is basically compressive. Okay, pressure is compressive. That is why we are getting the negative sign. So which would be the correct option? So the correct option would be 3 gm divided by 8. So in the denominator it is coming out to be 8. So 3 gm square 8, but it is not pi square, it is just pi. So correct option is our A option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.